Hello students, welcome to Physics Pathshala. Let us study uniform circular motion. Circular motion indicates motion of an object in a circular path, whereas uniform indicates speed of the object is constant. If an object moves in a circular path, it at certain time position of object is at A, after some time it reaches B. At each instant of time, velocity direction is tangential to the circle. Here, if we take the magnitude of velocity, that is speed is constant, whereas direction of speed changes throughout the motion. Now, we know for a circle, if it makes an angle theta and arc is L, radius is R, then this circle relation is theta is equal to L by R, where L is length of arc and R is radius of the circle. Again, we know linear velocity is displacement by time, or speed is linear distance by time. If time duration t becomes delta t and delta t tends to 0, then this L becomes S. Here we get that theta, where theta is the angular displacement, then angular speed is omega, whereas it is the magnitude of theta by t. It is similar to if S is the linear distance and velocity speed is S by t, velocity becomes displacement by t. Now, omega is our angular speed. We got theta is equal to L by R, when the time duration tends to 0, this theta becomes so small and this r becomes s by r. Then omega, which is theta by t, becomes 1 by r s by t is equal to 1 by r into v, or writes that v is equal to r omega. Now the acceleration is change in velocity, we know at each instant velocity of the object changes, though its magnitude remains same. As its direction changes, velocity also changes. Like it is v1 at this point and v2 at this point. Then v2 minus v1, like it is delta v. Change in velocity per time or rate of change of velocity. Change of velocity is delta t by delta v by delta t. Then if it is, say, position vector r1 and position vector at this point is r2, now we find out r2 minus r1 is delta r using vector addition. We know if it is vector A, this is vector B, and this vector C. Vector C is addition of A and B. Again, suppose there is a vector A and this is D. It indicates is equivalent to this is vector A and this becomes minus D, then this becomes A minus D. See this. Let this vector is now A minus D. In same way, delta R, the vector that is R2 minus R1, whereas delta V is V2 minus V1. Now comparing these two triangles, we find that delta V by delta r is equal to 1 by equal to v1 by r1, and magnitude of v1 is let v and r1 is r. Now we find that acceleration, which is delta v by delta t, is v by r into delta r by delta t. Using this equation, find that v by r into this delta r by delta t, when t becomes very small, this delta r becomes our s, that is s by t, and t tends to delta t, t becomes delta t, that becomes 0. Then this becomes v by r into v. This indicates a is equal to v into v by r is equal to v square by r. Summarizing this, now we find delta v, which is equal to v2 minus v1. The direction of this v is, direction of this delta v is radial, that is along the radius towards center. Acceleration is delta v by delta t. Again, the direction of this a is towards center along the radius of the circle. Hence, this acceleration is termed as centripetal acceleration, and its magnitude is v square by r, or v is equal to r omega square by r, or omega square r. In terms of frequency, we know omega is twice by mu, where mu is frequency of the rotation of the object, where it is number of rotations per second or per unit time, say per second. Then acceleration becomes 4 pi square mu square r. In next class we will continue our study on vector.